So hello everybody, welcome to my YouTube channel Java Guru Ravi, and I Ravi Khan Sahu welcome you in this new video. So let's get started. So hello everybody, today we are going to discuss primitive data types in Java. So primitive data types are basically the data types which we use to create the variables, and the Java programming language, as I have already told you, is a strongly typed language. So whenever you create any variable, so you have to mention its type. So in case of Java, we have 8 primitive data types, and I have already listed all of them here. So let us understand almost everything about these primitive data types. So first of all, broadly, if you see here, different types of data types are mentioned here. So if you see here, there are 6 numeric types. In the numeric type, we have byte data type, then we have short, then we have int, then comes long. So these are for the number type. Number type means whole numbers. So you can have 4 data types for storing whole numbers: byte, short, int and long. And if you talk about the floating point numbers, so there are 2 data types provided for floating point numbers. One is the float and second one is double. So the difference we will understand. The difference is the precision. It's all about the precision and the size. So if you talk about the 6 numeric data types, so we are having some compatibilities here. These 6 numeric types are compatible with each other, and we can assign one type of value to some other type of variable, and we'll be understanding all these things. But there are 2 other data types. One is boolean and the second one is char. So about these data types, there are some important points. First thing is, in case of Java, boolean is not containing the value 0 and 1. In case of Java, boolean is just storing 2 values. One is true and second one is false. And true and false are the reserved words. True in all lowercase and false in all lowercase. So these are the 2 possible and permittable values for boolean. There is nothing called as 0 for boolean in Java or 1 in Java. So only true and false, that too in the lowercase, because I told you it is a reserved word. Apart from those 50 keywords, there are 3 reserved words: true, false and null. So they are not keyword but they are reserved. So we are using true and false for the boolean. Right? Second thing about the char type. So if you talk about the char type, so in case of char, we have the size equal to 2 bytes. In case of Java, I have already mentioned, again I am repeating the same thing, that in case of Java, memory allocation is done by JVM. So the memory assigned to every component of your program, maybe data type, maybe object, everything remains constant. Right? So in case of Java, character is assigned the size that is equal to 2 bytes. The size of the char in case of Java is 2 bytes. It means it is 16 bits. Right? And unlike the C++ where the size of the character is 1 byte, here it will be having 2 bytes. And it will remain across every platform, whether it be a 32-bit system, whether it be a 64-bit system, character will remain 2 bytes only. So these are not compatible with these numeric types. Later on I will tell you char is having some kind of compatibility with the numeric types. So we will be discussing that also. But for the time being, we are going to concentrate on these numeric types. So as I told you, 6 are the integer type: byte, short, int and long. And then 2 are the floating point numbers: float and double. So size is mentioned here. Byte is 1 byte, short is 2 byte, int is 4 byte, long is 8 byte, float is again 4 byte, and double is of 8 bytes. So this is the size. Now if you talk about this numeric type and floating point type, means integer type and the floating point type numbers. So here this order is called as precision order. If you call this ordering, so this is the order of precision. Order of precision. This is not the order of size. Why? Because you can see here long is 8 byte, but float is only 4 bytes. Still float is having higher precision than the long. The precision of float is higher than the long, although the size of long is high. So it is not the order of size, it is the order of precision. Means float variable can hold more precise value as compared to long, like 1.1. If you store 1.1 in long, it will become 1 only. But if you want to store some float value like 1.1 or the value of some other floating point number, the float will be storing the precise value. But in Java, if you want to store some floating point number, so preferred type is double, because its precision is high. It is taking 8 bytes, it means 64 bits, whereas the float is having only 4 bytes, so its precision of double is higher as compared to float. And that is the reason why Java is assigning every floating point number in the double variable. Whether you talk about any predefined function, whether you talk about any predefined floating point values, all those floating point values are stored in double type. The reason should be very clear, it is having higher precision. If you want to store the value of pi, so the pi value is supposed to be having maximum precision, because if you want to calculate the area of some circle, so pi r square will be making a large impact if your precision level is low. So that's why double is preferred. That's why there are two lines I am going to state here is, in case of Java, the first point is, by default every number, let's say I said 5, so 5 is int. By default every number is int. By default every number, or you can say integer, is int type. Right? If I say 5, so 5 is by default int. Similarly, by default every floating point number is double. If I write 1.5, so 1.5 is by default double. Right? So there are two important points here we have to understand. Let's say I want to store some mobile number. Right? I want to store some mobile number. So which data type we can use here for storing the mobile number? So here we have to understand the concept of range. So what is the range here? If you talk about the range of every data type. So if I talk about the range of numbers, range of integer type, so how you calculate the range of integer type? Range of integer type is from minus 2 raised to the power number of bits minus 1. From here it will go up to 2 raised to the power number of bits minus 1 and minus 1. This is the range of any integer type. Means if I have to calculate the range of byte, what will be the range of byte? Minus 2 raised to the power number of bits in the byte is 8 bits. So 8 minus 1, 7. It means the byte range will be minus 2 raised to the power 7, and it will run up to 2 raised to the power bits minus 1, it means 7 minus 1. It means it turns out to be minus 128 to 127. This is the range of the byte type. Okay. Similarly, if I want to calculate the range of, let's say, short, the short size is 16 bits. 16 bits means minus 2 raised to the power 15, and from there up to 2 raised to the power 15 minus 1. Similarly, the range of the int type will be minus 2 raised to the power 31 to 2 raised to the power 31 minus 1. Right? So this is how you can calculate the range of any integer type. Integer type means byte, short, int and long. Fine. So this is the first thing. But suppose I want to store the some mobile number. So how will you store the mobile number? So let's say here we have the concept of representing a number. So two things we have to understand is, let's say you want to represent some long number. Let's say I am saying, okay, my mobile number is going to be some long type of variable. So how I will be writing? Let's say my mobile number is 8449261581. So this is my mobile number. So if I want to write something like this, so this statement is going to give me a compilation error. Right? This statement is a compilation error. The reason being that this value, this is an integer literal, and this value is supposed to be int by default. But this is going beyond the range of int. So if it is going beyond the range of the int, it will say it is incorrect. You cannot compile this. So how you will represent? I am saying okay, this is a long value. So if you are supposed to write some long value when the value is beyond the range of int, but it is inside the range of long, so you have to append L here. You can append L here to indicate that this is a long variable, long value. Right? So when you append capital L or small l at the end of your number, it will be considered as a long value. Right? This is not required in case of byte, short and int, but it is required when you have the value which is beyond the range of int. So it will be always appended with some L value, L character. So it will say, okay, this is not an int, this is going to be a long value. Similarly, for the float type, if you want to represent some floating point number, so that has to be appended with F. F character you have to write. Let's say I want to store some data here, float, let's say CGPA, and I want to write my CGPA is 7.19. So this statement is again a compilation error. This statement is compilation error. Why? Because I told you what is this? This is a floating point number, and floating point number is by default double. And I am trying to assign a double value to a float type. So this is called as type conversion. Right? It will give you incompatible types, but for the time being, if I want to make sure that this will be considered as a float type, so you have to append here F. You can append capital F or a small f. So this will be considered now a float variable, float type of value, sorry. Right? So these are the two important points. Again reminding this thing, if you have to represent some long literal long value, you have to append it with L. If you have to represent some float value, you have to append it with F. It may be uppercase, it may be lowercase, doesn't matter. Right? So this is about the 6 primitive data types. So I told you these 6 primitive data types are compatible with each other. Compatible with each other means they can be assigned to each other. Otherwise, the concept says that if you have some byte type of variable, so only byte type of value can be assigned. If you have some long type of variable, so only long type of value should be assigned. So it should be same type. But here, in case of integer types and floating point types, means overall numeric types, we have some compatibilities. So what is this compatibility? Compatibility says that one type of value can be assigned to other type of compatible variable. One type of value can be assigned to other type of compatible variable. Means first concept I will be discussing here is for integer types. So for integer types, it is saying that if you want to create any integer type of variable, let's say byte, short, int and long. So integer types are saying, okay, during the declaration, you can assign me any value which is within the range. Within the range, if any value is there, you can assign it. Means what I am saying is, I am saying let's say I am creating a byte variable. I said byte b. So byte b is a byte type of variable. It means we can assign only byte type of value. But if I write here 10, so I told you 10 is by default int. So I am trying to assign int to byte. So it should be incompatible types, but integer types allow you this thing. It allows you to assign even the int type of value to the byte type variable when it is within the range. It is within the range of that type. So 10 is within the range of byte because byte range is minus 128 to 127. It means when you create some byte variable, you can assign any value within the range from minus 128 to 127. No issues. It will not ask for any kind of compatibility issues. Right? So I can write something like this. Byte 100 is also allowed. But as soon as you try to assign some value which is outside the range, it will create an issue. We'll be talking about that concept. So I hope you got this point that during the declaration you can assign any value which is within the range. So this statement is correct, but if I write this statement, byte b1 is equal to 200, so this statement is incorrect. This will not compile. The reason being 100 is within the range of the byte, but 200 is not within the range of the byte. Fine. So this concept is working for the integer types. Integer type allow the value to be assigned of any type when it is within the range. Now coming to the concept of narrowing and widening. There are two concepts. One is called as narrowing and other is called as widening. So this is very vital concept and you have to understand it properly. So first of all, what is widening? So what is widening? Widening is very easy. First of all, widening is automatic. Means we need not to do any kind of coding for the widening. Widening is automatically, it is implicit, you can say. So what is the meaning of widening? Widening says that assigning a lower precision value to a higher precision variable. Right? And the precision order I have already told you. These 6 types are compatible and their precision order is the same. So widening says assigning a lower precision value to a higher precision variable. What I mean to say is, let's say I have written here long x is equal to 10. Just try to understand here long x. So what type of variable it is? Long type. So long type of variable, and what type of value it is? It is int type. So I am trying to assign int to long. So int value is of lower precision. You can see here int is of lower precision and long is of higher precision. So assigning a lower precision value to a higher precision variable, it's okay. It is automatically. We need not to write any kind of code here. This will be working. Similarly, if I write another code here, let's say I write here float f is equal to 5. So again this statement, if you see here, f, this value is of int type and I am trying to assign it to f is of float type. So int is lower precision and float is higher precision. It means assigning a lower precision value to a higher precision variable. So this is widening. Widening means it will be contained in the f and it will become 5.0. Right? So this is again allowed. There is no problem here in this case. So widening means lower precision value you are assigning to some higher precision variable. So obviously there will be no problem because you are not going to restrict some values, right? But on the other hand, if I say, let us assign this kind of value. Let's say I am saying, okay, int x is equal to 1.5. So if you see here, what is this? Int x is equal to 1.5. So if you talk about 1.5, what is 1.5? This is of double type, right? So double type of value I am trying to assign to a variable which is of int type. It means double to int. So if you see here, double to int means we are going against the precision order. It means assigning higher precision value to a lower precision variable. So So assigning a higher precision value to a lower precision variable, this concept is called as narrowing. Means I am going to assign some higher precision value to a lower precision variable, means there are chances of losing some data. That is why it is called as possible lossy conversion. Possible lossy conversion means you can understand from here, if you will write 1.5 and we will try to assign to x, so definitely x is an int type of variable, it cannot store the 1.5. So it will be losing some fractional part from here and it will make it only 1, right? So it will be converting it, it means it will be losing some data, lossy conversion, but it has to be given as a permission by the programmer. It will not work automatically, it will give you compilation error, right? You have to give this permission, it is called as explicit conversion, explicit typecasting you can say. So narrowing is always explicit, means programmer will have to allow this. So how you will write this code? You have to write something like this, int x, and narrowing means you have to mention here what type you want to convert it. So I want to convert it into int. So in the brackets you will be writing, in the parenthesis you will be writing the type in which you want to convert and the value 1.5. So it means now it is saying okay, I am allowing 1.5 to be converted into int. So it will be converted from 1.5 to 1 and 1 will be assigned to int x, and if you print here the value of x, so you will get the output as 1, which is lossy conversion. The value has been lost. We don't have the value of x as 1.5 now. It has been lost, right? So this is the concept of narrowing. Again repeating, narrowing means assigning higher precision value to a lower precision variable. It means you are going to lose some data. It is called as lossy conversion, and because it is something which is lossy, so it is explicit. You have to mention up to which level you want to allow the conversion. So this is the level in which you want to convert it, right? So widening is automatic, we don't have any problem. I want to make 1 to 1.0, no loss. But if I want to make 1.1 to 1.0, yeah, 1, this is lossy. So lossy is explicit, narrowing, widening is implicit, and it is automatically assigned, right? So in the numeric types, it is type conversion. Now if we talk about here one more important concept in the widening and narrowing only, let me talk about this thing. I am saying okay, let's create a variable. I am writing here float x is equal to, let's say 1.1. So if you understand this statement, if you try to compile this statement, I have already told you this will not compile. The reason is the variable is of float type and the value is double type. I told you by default every floating point number is double. So this is double to float, narrowing. Double to float is narrowing. So you are going to do the narrowing here. So narrowing is explicit. So I told you there are two ways. Either you make it float only. How you make it float? You will be writing here like 1.1 f. But let's say I am not going to write it here. Maybe you are receiving the value from the user. So you cannot make it 1.1 f. So what you can do is, you have the other way, that is type conversion, means narrowing. So if you have received this value from somewhere, so what you have to write here is, you will write here, let us typecast it. Right? So this is also correct. I will be receiving this value. I cannot make it 1.1 f, no problem. I will be using the concept of explicit typecasting, that is narrowing. Right? So I hope you understood the concept of narrowing and widening. The order is again byte, short, int, long, float and double. Again reminding important points. this is not the order of size, this is the order of precision. Second important point, widening is automatic, and widening is assigning a lower precision variable to a lower precision value to a higher precision variable. And narrowing is explicit, it is lossy conversion, it is assigning a higher precision value to a lower precision variable, right? One more important concept here is that typecasting the expression means expression typecasting. So expression typecasting means, let us take an example here. Let's say I am having some integer, let's say balance, and I am saying ki, okay, I am having some double value rate of interest which is 3.9, and I am having some integer amount is, let's say 2000, and I am having time is let's say 4.5 years. So suppose this kind of scenario is given to you and you have to calculate the interest, right? So this is interest. Let's say I want to calculate the interest, simple interest I want to calculate. So what I can write here is interest is equal to, obviously I will be writing amount multiplied by rate of interest multiplied by time, and then divided by 100, something like this. But the problem here is amount is int, amount is of int type, and rate of interest is of double type. So there is a property I am telling you, although we will cover in the operators, but the property of the arithmetic operator is that whenever you apply the arithmetic operators, so what is going to happen here is that it will take both the operands, and first of all it will convert them minimum to the int type. Arithmetic operators work with int type only. So if you have both the both the operands of byte type, still it will convert into int. Minimum promotion will be done up to int. But if any of the operand is of some higher precision type, it means suppose I am having one operand is of byte type and second operand is of long type. So what will happen? Though both the operands will be promoted to long type, right? So it will check out of the both the operands. If any operand is having higher type than the int, so both the operands will be promoted to that higher type. But if none of them is higher than int, so both will be promoted to int. So minimum the operands type will be int only. You cannot have anything called as byte when operated upon. So let's say I am taking one byte, one long, so overall result will be long. If I am having one int, one float, overall result will be float. If I am having one byte and one short, the overall result will be int, right? Byte, short, both will be promoted to int. So here if you see, amount is int type, rate of interest is double type. So result will be double. Now double into time, time is again double. So double into double, double. Then divide by int, so double, double. Int will be promoted to double. So here if you see the type promotion, or you can say widening, it is widening which is going to happen automatically. That's why we need not to write the code here. So here amount will be promoted to double, right? Because the second operand is of double type. Then the result will be, then time is again double, this is again double, then it will again be promoted to double. So here two values are going to be widened. Two values are going to be widened. Amount is going to be widened and this 100 is going to be converted to double type. So this is how the overall result will be double. But now I am going to assign it to interest which is of int type. So overall result is going to be of double type and I am trying to assign into int type. So double to int conversion is narrowing, right? Double higher precision value to a lower precision value. This will be narrowing. So how narrowing will be done? We have to do it explicitly. Now what the mistake we are doing as a beginner level programmer, will be writing like this. Right? And if you write like this, it will give you a compilation error. Why? How the compiler will interpret this? It will say, okay, you want to convert int. You want to convert into int. What do you want to convert? Amount. So amount is already int. No problem. But again, this int multiplied by double, so it will become double and it will say lossy conversion, because the overall result will be again double. So what we have to do here is, we have to convert we have to typecast the entire expression rather than narrowing or typecasting individual values. You have to typecast the entire expression to get the more precise result, right? Otherwise, if you will convert individually rate of interest and time, so what will happen? Rate of interest will become 3 and time will become 4, which is wrong, right? Instead of typecasting individually to rate of interest and time, you should typecast the entire expression. First of all, the overall calculation to the most precise result will be done, and then if the result is, let's say, 109.1, it will be converted to 109, right? If you individually typecast it to just see the result, amount is 2000, then rate of interest, if you type in rate of interest individually, it will become 3, and then time is 4 if you typecast it individually. So it will be giving you 20 into 3 into 4 means 240, right? But actual value should be 3.9 into 4.5, right? So it will be much higher than the individual typecasting. So I hope, rather than typecasting the individual values, you must prefer typecasting the entire expression. This is very important. Fine. So after narrowing and widening, in case of these 6 numeric types, now we'll understand the compatibility of character also. So boolean is first of all not compatible with any of the 7 other data types. Boolean is not compatible. You cannot assign boolean b is equal to 0. Not compatible at all. Forget about this. The 7th type, which is char. Char is still compatible with the integer types. Char is saying, okay, I am compatible with integer type. So what is the important point here is, you have to understand this thing, that char says during the declaration, char variable can be assigned some integer type of value. But the condition is it should be within the range. So what is the range of the character? Character range is, range of the character variable is 0 to 65535, right? Because what is the size of the character? 16 bits. So it will be ranging from 0 to 2 raised to the power 16 minus 1. This is the range, right? So 0 to 2 raised to the power 16 minus 1. Character only allows the positive values. There is no character which is having some negative value. ASCII value it is. So 0 to 65535 is the range. It means it is saying, okay, if you want to create some character variable, no problem, you can assign some int value, provided that that particular int value must be in the range. So it means, what I can say here is, I can say that if I am creating some char variable, let's say c is equal to 65. So this statement is allowed. Means you can write char c is equal to 65. this statement is allowed. But again repeating and emphasizing on this point, you can just assign the integer type of value. This is very important question and is asked in the Oracle certification exam as well. If the same statement I will try to write this, int x is equal to 65, and I will write here char a is equal to x. X is an int variable which is holding the value 65. So I am trying to assign actually the 65 value to char a. It is similar to this statement where char c is equal to 65. But this statement is allowed, this statement is wrong. This statement is wrong because char has just allowed you to assign some int type of value. It is not allowing you to assign int type of variable. Right? During the declaration, you are just given the leverage that okay, you can assign some int type of value, means int literal only. Int variable cannot be assigned to char type of variable. So it is just partially allowing the compatibility with the int type. But yes, if you want to execute this statement, you have to use the concept of type conversion, type casting, and from every numeric type to character, conversion is narrowing. Numeric type to character conversion, whether you convert a byte is 1 byte and you want to convert into what? Int. Sorry, char. So byte to char it should be normally precision level, if you see here, so it is widening, but it is not widening. Any numeric type, if you are trying to convert into char, it is narrowing. It is not widening. Right? So it means if you write something like this here, if you write here, I have written byte b is equal to 65 and you want to write here char c is equal to b. So you cannot say sir b is byte and we are assigning the lower precision value to a higher precision value, it is widening. No. Character is compatible, but every kind of assignment here in the numeric to character is narrowing. Explicit typecasting, you cannot execute this statement. You will have to write it like this. That's it. This is correct, this is wrong. Right? So this is all about your narrowing, widening and data types. I hope you understood, and if you have any doubts, any queries, so you can ask in the comment box. Thank you.
So I hope you enjoyed this video, and if you find this video useful, so please like, subscribe and share with all of your friends so that they can also get benefited. Ravikant Sahu signing off. Thank you.